All right, so we're going to cover 9.2 lines of fit. Let's go over the vocabulary. You have the line of fit, a line drawn on a scatter plot close to most of the data points. It can be used to estimate data on a graph. Line of best fit, a line of fit created using a graphing calculator through linear regression. It is the line that best models the data. R value, a value assigned to a line of best fit. If the number is close to -1, that means negative correlation. +1 means positive correlation, and 0 is no correlation. Okay, so let's go ahead and have these vocabulary terms in our notes. All right, so let's go ahead and take a look. 9.2 lines of fit. Table shows the depth of the river X months after a monsoon season ends. So in the first column, we have the number of months from 0 to 8 and the depth of the river, or how deep the river is. And we see it's descending from 20 down to 5. We're going to make a scatter plot of the data and draw a line of fit. So first off, we'll go and plot the points. Once we plot the points, we can go ahead and draw a line of fit. Now, the line of fit, you want it to go through as many points as possible with equal amount of points above and below it. Now, it's not always going to be an even number, right? But the point of it is that you want the line to go through as many points as possible because this line here is pretty much showing you what the data is doing. And in this case, the data is trending downward. Now we're going to have to write an equation for the line of fit. We're going to go ahead and figure out what's the slope in the y-intercept, and we're going to use y equals mx plus b. So the line passes through 5, 10, and 6, 8. So we're going to use the slope formula, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, to give us negative 2 over 1, which is a slope of negative 2. So this graph here has a slope of negative 2, and we see that its y-intercept is at 20. So we'll go ahead and plug in our values. So instead of m, we put negative 2. Instead of b, we put 20. And we get the equation y equals to negative 2x plus 20. So just to recap, we had to first find the slope by picking 2 points. Usually we want to pick the y-intercept as 1 point and then another point on the line. Find our slope, use the y-intercept, plug it into y equals mx plus b to give us our equation. Now we have to interpret the slope and the y-intercept for the line of fit. So the slope is negative 2 and the y-intercept is 20. That means that the depth, or the river, is 20 feet deep at the end of the monsoon season, and after 9 months it goes down to a depth of 0, and it decreases 2 feet every single month. So again, when they ask you to interpret the slope and the y-intercept, they're asking you to give it meaning. What do the numbers mean? And in this case, the y-intercept is telling you how deep the river was in the beginning, and the slope tells you how much water, right, is the river losing by feet every month. And in this case, it loses 2 feet every month. Here it says predict the depth at month 9. So all we have to do is we have to look at our line of fit, find the month 9. So these are the months. Month 9 is right here. We go and follow it up to the line, and we see that it has a depth of 2. Now, another way we can do it is we can also use the equation that we wrote and plug in 9 into the equation. And when we do that, we get negative 2 times 9 plus 20. Negative 2 times 9 is negative 18. Add 20 to that, you get 2. So that shows us that at month 9, we would be at 2 feet. So you can either use the equation to figure it out, or you can just look at the graph. All right, here's the next example. The table shows the numbers of people who have attended a festival over an 8-year period. Make a scatter plot of the data and draw a line of fit. Write an equation of the line of fit, interpret the slope and the y-intercept of the line of fit. Predict the number of people who will attend the festival in year 10. So in your notes, I want you to try to do this on your own, right? First, plot the points. Once you've plotted the points, try your best to draw a line of fit. And then you're going to go ahead and write what do the slope and the y-intercept of the line of fit, what do they represent? And then figure out at year 10, how many people will there be? Okay, so now hopefully you're done. Let's go ahead and check our answer. So once you've plotted the points, this is what your point should look like. And then we're going to draw a line of best fit through these points. And as you can see, our y-intercept is at 0, okay? And our slope is going to be 270. So the slope shows that the attendance increased by about 270 people each year. The y-intercept shows that the attendance in the year prior to this 8-year period was 0. And at year 10, we should expect there to be 2,700 people in attendance. Now, if your answer is close to this, but not exact, that's fine. Again, when we draw lines of best fit, our lines of best fit won't always be the same, right? But what matters is that they're going to be very close to each other. See, so your slope may be different. Your y-intercept may be different, but not by much, right? It will still give us very close values. Here's another one. It says, which equation represents an appropriate line of fit for the data in the table? Okay, so go ahead and try this one on your notes. Okay, if you're done, let's go ahead and check our answer. All right, so here are the points, and here is a line of fit. And as you see, our line of fit is going through as many points as possible with an equal number above and below it. Okay, here it says the table shows the worldwide movie ticket sales, Y, in billions of dollars from 2000 to 2011, where X equals 0 represents the year 2000. Use a graphing calculator to find the equation of the line of best fit. Identify and interpret the correlation coefficient. All right, so now I'm going to show you how to use a graphing calculator to pretty much do what we've been doing by hand. And it's going to make this whole thing really simple. So this is Desmos, right? So you have Desmos website. And this website's really great because it helps you do problems that require a graphing calculator. And if you don't have one available because they're very expensive and they're actually the same type of graphing calculator that I used when I was in middle school, which is strange, right? Something that old is still costing over $100. You could just use Desmos. So we'll go to desmos.com, click on Start Graphing. Now, first thing we want to do is you want to make our table. So we'll go ahead and hit this plus sign here and hit on table. So notice you have x sub 1, y sub 1. And remember, the only reason why there's that subscript 1 is to show you that these values belong to the first table with the x and y value. So now we'll go ahead and enter it in our values. So you got 0, 1, 2, 3. Now notice that I'm not typing anymore. I'm just hitting enter. It's just automatically putting it in for me all the way down to 11. Okay, so now go ahead and put in my y values. I got 16, 17, 20, 20, 25, 23, 26, 26, 28, 29, 32, 33. All right, so over here, you're probably looking at it and wondering, well, where are my points? Well, again, this only goes up to 14, this only goes up to 10. If you want to see the points that you just plotted, you have to zoom out. And these are the points that we plotted right here. Now, we're going to go ahead and ask the graphic calculator to make us a line of best fit, right? Instead of trying to guess and check ourselves. So the way we do that is this. We're going to go ahead and enter expression. And we're going to type in y sub 1, right? Because we're using y sub 1 from here. And now, remember that the line, right, the slope-intercept form is y equals mx plus b. So I don't want just a line. I want a line of best fit. So I'm going to go ahead and use this symbol here, okay? Instead of equal sign, we'll use that symbol there. So y is equal to mx, so mx1 plus b. And there you go. That is our line of best fit for this data here. And what's really interesting is that you see we have our R value, that's 0.98. And remember in the vocabulary, we said that if you had a positive 1 or something that's close to positive 1, that meant you have a positive correlation. If the R value is 0, that meant there was no correlation. If the R value is negative 1 or close to negative 1, that means there's no negative correlation. It also gives us the slope and the y-intercept for our line. So our equation for this line is y equals to 1.50669 or 50699x plus 16.2949. That would be the equation we would use for this line of best fit. So as you can see, having a graphic calculator makes doing this type of math extremely easy. And luckily we have Desmos to allow us to do it for free as long as you have an internet connection. And that's it. All right, that will be all for this lesson. I'll see you guys next time.